All right, when you're looking at polynomials, again, written in standard form, from highest power to lowest power, the coefficients are the multipliers in front of the x. The powers of the variables have to be whole numbers. The number at the end with no variable part to it, again, this isn't actually written down, is your constant. The degree of the term simply represents the exponent, whatever the power is. So this individual term has a degree of 5, so it's a 5th degree term. This term has a degree of 3, it's a 3rd degree. This one is 2nd degree. This one is 1st degree. And when you're looking at a constant has a degree of 0. In addition to the degrees, they have some names, some classifications based on those degrees. If you have a 0 degree term, the classification is constant. And so if you're asked to classify by degree, anything with a 0 degree term or a 0 degree is classified as a constant. A 1st degree expression is classified as linear. It's a linear expression or linear equation or linear function. And we've talked about those already. 2nd degree are what we just talked about in the last chapter, which were called what? When you did a regression on powers of 2, what kind of regression did you do? You remember? We did linear regression when the power was 1, straight line. A quadratic regression. So when you're classifying by degree, you have a quadratic. A 3rd degree is classified as a cubic. 4th degree, which isn't included in this, but I'll write it down here. A 4th degree term or expression would be classified as a quartic. And anything beyond that is just going to be classified as a polynomial. Okay, the last thing that you need to be aware of regarding polynomials is they can be classified also by the number of terms. And so if you have a polynomial with just a single term, so it could be something like x squared or even negative 3x squared. It could be something like 5x. It could be something like just a number, negative 2. These are all called monomials. And so you should be familiar with the prefixes, one term, the prefix representing 1 is mono. So a monomial has one single term. If you have an expression or polynomial with 2 terms, so that would be something to the effect of x plus 1. You could have negative 3x squared minus x, and so on. 2 separate terms to it. What's a prefix that represents 2? Bi, right? Like a bicycle, biannually. So a binomial simply means a polynomial with 2 terms. And if you're dealing with a polynomial with 3 terms, so looking at 3x squared minus x plus 7, or x to the 5th minus 2x plus 1. These would be examples of, and what prefix means 3 is tri. So trinomial. Again, anything beyond this is just going to be classified as a polynomial. Okay, so this is classifications by the number of terms. All right, what you're going to be asked to do with respect to polynomials beside identify these classifications is right now you're just going to combine them. So to combine them, you're just going to add or subtract polynomials. Okay, so if we were to take a look at some examples of that, if I gave you 5x squared minus 4x plus 1 and asked you to subtract 8 minus x squared, okay, see if you can identify what the simplified form would be for these. Okay. All you're doing is you're combining like terms. You may need to use the distributive property. If you're subtracting, the easiest thing to do if you're writing it out by hand would be to take whatever you're adding or subtracting and just stack it vertically over like terms. So we have all of our terms, x squared, x's, and constants. We distribute our negative, we get a minus 8, so I'll write that beneath the constant. And a positive x squared, I'll write that beneath the, again, second degree term. And now if we just combine straight down the column, we would get our answer of 6x squared minus 4x minus 7. And this would be our expression. Now, is this in standard form? Highest power to lowest power? Yeah, so you need to write it in standard form. And how would you classify this based on number of terms? It's a trinomial. And how would you classify it based on the degree? Second degree, which is quadratic. And so, again, as far as what you would need to be able to do is add and subtract, so combining polynomials, identifying them in standard form, and then classifying them by degree and by the number of terms. Okay, so try this one just really quickly, and then I will let you. So when you're doing this by hand, again, if you're setting this up by hand and solving it, easiest thing to do, distribute your negative, and then just stack them in like columns. So our negative distributes to the x squared. We get negative 2x squared. A negative x becomes a positive x. Align it under the like term, and then a negative 6. And then just combine straight down your columns. Now, when you do this, okay, combining your x's, you get 3x minus 3, and you get a negative 7x squared. Is this written in standard form? Highest power to lowest? No. So you do need to adjust the order of the terms. So which term do we need to write first? So we get negative 7x squared followed by 3x followed by negative 3. So here would be your answer. It winds up fitting into the same classifications, right? It's a quadratic, a second degree highest power, and then it's a trinomial also. All right, if it's asking you to classify the whole polynomial, the classification for the entire polynomial is just whatever the classification of its highest degree term is. Okay. So that's where the quadratic and expression would come into play as far as classifications. All right, now if you're using your calculator for this, even easier, right? If you can enter the correct symbols, if you take 5x to the second minus 4x plus 1, and then subtract the quantity 8 minus x squared, hit enter, it'll give you the answer, and it should also put it in standard form for you.